Hello there. Let's you and I check this problem out together. This is a nice problem. A beam, 4 meters long, and it's sitting on two fulcra, and these two fulcra are 1.8 meters apart. Okay. The beam is 15 kilogram, and there is a cat that happened to walk from this right side all the way to the left side and passes over the left fulcrum, and it seems that the cat is going to keep going. Now we don't know what's going to happen. Is the cat heavy enough to knock the beam down and destabilize the beam? Then the system is not in equilibrium anymore. Basically, the question is the cat safe? Can the cat go all the way to the edge without knocking this over? That's the question. Now that's a tricky problem. There's many ways to do it, but the best way to understand is that if the cat keeps going this way and it destabilizes the beam, this means that the cat will lift up the other side of the beam here such that it's not touching this fulcrum anymore. Okay, so it's like this fulcrum does not exist. This is only the fulcrum that the beam is going to what? Rotate about. So this will be our axis of rotation. Okay, let's draw the free body diagram. Here's the free body diagram. So there's no fulcrum here, so there's no N1 or N2. So there's only here our what? Axis of rotation. And the cat is here somewhere. So that's the cat. And the cat has a weight equals 10 kilograms times 9.8, which is 98 Newton. At a distance x, we don't know, that's the distance x at which the beam is going to be rotating or knocked over or destabilized. And the other side here that is acting on the beam from the other side is the center of gravity of the beam. So that's the center of gravity of the beam here in the middle. And the center of gravity of the beam is equal to 15 times 9.8, and that's 147 Newton. So this is the axis of rotation. This is the weight of the beam acting on one point. We called it the center of gravity. And this is what? The weight of the cat. If the cat moves a little bit here, we understand, assuming that what? This whole system will be knocked down. Okay, so this is the last point of equilibrium, so to speak. All right, so that's the best way to approach this one. So if this was the axis of rotation, and this is gonna try to rotate it this way, so rotating it this way, that's what? That is counterclockwise. And this one here is gonna try to rotate it this way, and that's clockwise. Okay? All right. So maybe I should choose the blue. I'm gonna say torques clockwise must equal to torques counterclockwise. To apply this equation here, we can find x, because x is the only unknown. Then if x here is bigger than this distance from here to here, then the cat is safe. But if x is smaller, then that's where the cat, if it goes just further to the left, the system will destabilize. Okay, so torques clockwise, so it's going to be, we know that the torque is equal to the force times r times sine theta. For all these forces, the arm of the force and the force, the arm of the force and the force, the angle is 90 degrees, so sine 90 is 1, so no worries about the angle. So we just have to multiply the force times r. The force of this one for the clockwise torque is 147 times the arm of the force, which is the distance between here and here. Okay, how do we find this? The beam is 4 meters long, and the distance between the two fulcra is 1.8. All right, so what's left outside here and here, we can find it, because 4 minus 1.8 is 2.2, and then you have two distances, one on the right and one on the left. So divided by 2, 2.2 divided by 2, so this would be 1.1 meters, and this would be 1.1 meters. Okay, so this whole thing is 2 from here to here, minus 1.1 meters, so this distance is 0.9 meters. Okay, all right, so the arm of the center of gravity force is 0.9 meters, and that must be equal to x, or the force of the cat first, times the distance x. Solving for x, we can find that x is equal to 1.35 meters. Okay, well, this distance between here and here is 1.1 meters, so x, which is the distance the cat can go to the left, is 1.35 meters. But what's left between here and here is 1.1 meters. So what do you think? Is the cat safe? The answer is yes, the cat is safe, because the cat can go 1.35 here, like maybe here, that's 1.35, without knocking the beam over. But this is not the distance 1.35. It's actually just 1.1. That's the total distance left for the beam. So the cat can still go, if the beam goes another 0.25 meters, it's still safe. Okay, and that's the answer for this problem. Thank you.